How to be Bachelor of Engineering. This lesson will discuss the pure capacitor in an electrical AC circuits. From this circuit, is connected to a supply voltage of 230 volts root mean square, and set the frequency to 60 Hz. For a moment, we enter random the value of capacitor, from 10 microfarad to 150 microfarad. It is automatically calculated the result of all values. The current of 0.867 ampere, a reactance of 265.25 ohm, an impedance of 265.25 ohm, an apparent power of 199.42 volt ampere, a reactive power of 199.42 volt ampere reactive, and a real power of 0 watts. Increase the value to 25 microfarad. The value of reactance and impedance is decreased, while the value of current and power is increased. Increase the value to 35 microfarad. Increase the value to 50 microfarad. Increase the value to 75 microfarad. Increase the value to 100 microfarad. Increase the value to 125 microfarad. Enter the final value to 150 microfarad. Did you observe a while ago? If the value of capacitance is increase, as a result, the value of reactance and impedance will decrease. Because, the reactance of an AC capacitor is inversely proportional to both capacitance and frequency of the supply as shown in this equation. What is capacitive reactance in a pure capacitance? Capacitive reactance, in a purely capacitive circuit, is the opposition to current flow in AC circuits only. The opposition to current flow is the electrostatic charge on the plates. If AC capacitance value remains constant, the capacitor is fully absorb the change in charge on its plates during each half cycle only. What is the impedance in a pure capacitor? The impedance of a pure capacitor is equal in magnitude to its reactance, but these two elements are not identical. Reactance is expressed in imaginary number. Impedance is written in a complex number. As seen in the result of impedance value, is the magnitude of 17.68 ohms, and phase angle of 90 degrees. What is the power factor, PF, in a pure capacitor? The power factor can be defined, is the value of cosine 90 degrees, the result is 0, and also, a power factor is directly proportional to power, and inversely proportional to apparent power. It is the phase angle difference between a current and voltage sine waves. As seen graphically in sinusoidal, a pure capacitive circuit, the current is leading by 90 degrees from voltage. In other words, the voltage is lagging 90 degrees from current. What is the value of current in a pure capacitive circuits? The current in the circuit can be defined from this equation, is equal to the applied voltage, and inversely proportional to impedance. The result is 13 ampere equivalent to root mean square. What is the apparent power in a pure capacitive circuits? Apparent power is directly proportional to applied voltage and the current. The result is 3.489 kV ampere. What is reactive power in a pure capacitive circuits? In this purely capacitive circuit, is supply reactive power of 2.991 kVAr, because with the current waveform leading the voltage waveform by 90 degrees. In the electrical systems, in order to compensate the reactive power absorbed by inductive loads such as motors, is required to add a capacitor in the circuit. We'll discuss next episode for power factor correction. What is the real power for pure capacitive circuits? As graphically shown, the instantaneous power, current, and voltage sine wave. In the positive half of the voltage waveform, between the angle of 0 degree and 90 degree, both the current and voltage waveforms are positive in value, resulting in positive power being consumed. Between 90 degrees and 180 degrees, the capacitor current is negative, and the supply voltage is still positive. The result of the product of voltage and current gives a negative power. As shown, in the instantaneous power sine wave, the maximum power is plus 2.99 kilowatt. This positive power indicates that the coil is consuming, or storing electrical energy. The minimum power is minus 2.99 kilowatt. This negative power indicates that the coil is returning stored electrical energy back to the supply source. The result of real power is 0. Means is prove that a pure capacitor in AC circuit does not dissipate power. Now, we slowly increasing the frequency from 60 Hz to 120 Hz, and observe how will affect the reactance and current in the capacitive circuit. As you observed, in capacitance circuit, when frequency increases, the reactance value is decreases, while the circuit current is increases. Because a capacitive reactance is inversely proportional to frequency. If the frequency increases, the current flowing into the capacitor increases in value. Since the rate of voltage change across its capacitor plates increases, we set slowly decreasing the frequency from 60 Hz to 1 Hz, and observed the effect as well in the circuit. From this presentation, if the frequency decreases, the capacitive reactance increases gradually. As a result, if reactance increases, the voltage across capacitor also increases. This is the reason the capacitor acts as an open circuit in the DC supply, zero frequency. That is for lesson for today. Thank you for watching. Please don't forget to subscribe to get notification. See you again next episode. How to be Bachelor of Engineering.